In this module, we'll learn how the communication is established between the application and the database server. We'll review the different configuration files related to network configuration, and we'll discuss the different ways we have to connect to a database. Let's have a high-level overview of what are the major actors involved in a distributed architecture. These are the client and the server. A client is any application that connects to an Oracle database. That could be an application server such as WebLogic or JBoss, or a tool in a PC, such as, for example, SQL Developer, Toad, or SQL+. A DB server is where one or more databases are servicing data. The client connects to the database server using a network protocol, probably the most common of which is TCP/IP. On the server side, we have the DB server software installed. On the client side, we have the DB client software installed. The DB client provides a means to make use of the DB server. In order for the DB client to establish a connection to the DB server, we need a communication mechanism. This is called OracleNet. OracleNet is a software layer that helps establish and maintain the connection between the client and the server. The client needs to be able to identify the database it wants to connect to. The database must provide this identification. One way the database does this is by the use of services. A service name is a logical representation of the database. One database can offer multiple services. Now let's walk through how the network connection is established. Let's assume we have two database servers. Server 1 with two databases, DB1 and DB2, and Server 2 with one database, DB3. Each database is independent from one another. When you create a database, it will provide a default service with the same name as the database itself. So for DB1, there is one service named DB1. We can add more services to each database, and it is advised each service to be unique to that database. Otherwise, unwanted results may occur. For DB1, we have three services, DB1, Online, and Batch. DB2 and DB3 have their own set of services. The use of services provides transparency to the application. It doesn't have to know what the database name is, just the name of the service. Now let's say that each server has its own listener, one per server, and each listener is listening on different TCP/IP ports. If properly configured, when the database is open, it self-registers with the listener. During this registration process, the database tells the listener which services are available for use on that database. You can create, modify, start, and stop services with the DBMS service database package. Assume we have three clients, PC1, App1, and PC2. Let's now say that PC1 wants to establish a connection to the database servicing online service name. It knows this service is on server 1 on port 1523. The listener will attend the request. If the service is listed in the service names, it will respond to the client acknowledging the existence of this database. The client then establishes a connection to the database. Similarly, App1 tries to establish a connection to server 1 on port 1523 to the payroll service name. The listener acknowledges the existence of the database and the application establishes the connection to this database. Then we have PC2. It wants to establish a connection to server 2 on port 1525, which both of these are correct, but it then provides a service name web. The listener doesn't recognize this service name and as such rejects the connection. Everything discussed here doesn't have anything to do with authentication or authorization. We are only establishing a network connection with a database. Once the network connection is established, the user will have to provide proper username and password. Now that we have a better picture of how the communication works, let's talk about how we can set this up in our environment, where to look to make changes to the configuration properties. We have two tools at our disposal to manage network configuration, netCA and netmanager. netCA is mostly used when we are initially setting up the environment, when there is no configuration yet. netCA will create all the required configuration files based on the info entered during the configuration process. Depending on what you specify for listener port during the creation of the database with DBCA, DBCA could run netCA to create the initial setup. Once the configuration is performed, you then would use netmanager for ongoing maintenance. netmanager guides you through all the different options you have to configure the network configuration files. You may skip the use of both these tools and modify the files directly with a file editor, but just make sure to avoid introducing errors to the file, otherwise the network configuration may break. There are three naming methods that could be used to connect to a database: EasyConnect, local naming, and directory naming. EasyConnect allows a client such as SQL Plus to connect to a database with only the hostname, port, and service name. You don't need any configuration file for this method. In local naming, the configuration is stored in configuration files, namely tnsnames.ora. This file needs to be maintained by the DBA on the server side, or usually done by the application admin on the app or client side. You would add all the databases this client has access to from that machine. Each database definition is called DBA alias or TNS alias. In directory naming, the network configuration is centralized in an LDAP compliant server, such as OID, Oracle Internet Directory. The clients will ask OID for the DB connection information. If the info is known, it will be provided back to the client. There are three configuration files related to network. These are listener.ora, which defines the network, port, protocol, and databases that this listener will be listening in for incoming connections. tnsnames.ora, which helps with database network resolution. And SQLnet.ora, which is the network profile. In here you can define the resolution preference, buffer size, and tracing and logging preferences. When using local naming method, you only need tnsnames.ora and optionally SQLnet.ora if you want to use non-default values. The server only needs listener.ora when using non-default values. For example, when using a port other than 1521, which is the default. The server provides both client and server software. That's why we can find the three files on the server. Let's open a terminal session to the server as Oracle, then run netCA. As explained before, netCA will help you with the initial configuration of the listener, naming methods, and directory configuration. If you select Listener, you will see that you can add, remove, rename, and reconfigure the local listener. Naming methods will let you choose the different naming methods that you are allowing on this server. Local net service will let you add, remove, reconfigure, rename, and test TNS aliases. And finally, directory naming will guide you through the steps to use OID as a database naming resolution service. netCA will do basic configuration of all these files. If you need to do advanced configuration, then you would use netmanager. netmanager can do the same functions as netCA, but also can do advanced configuration. Let's start netmanager by typing netmgr. Let's expand net configuration, and then local. We have profile, which is another name for SQLnet.ora, service naming, which is tnsnames.ora, and listeners, which is listener.ora. Let's quickly review Profile. You can set the preferred naming methods order, tracing and login features, among others, and network security. Service naming lists all the TNS alias we have defined on this host. You can add more services by clicking on the green plus sign on the left. If you select an alias, you can change connection type, change the hostname, port, add more addresses, etc. If you click Advanced, you can specify the buffer size. Click on Listener. You can see the current addresses that is listening on. You can add or remove addresses. You can change server-side tracing and login. You can manually add database services. This is useful when you don't have automatic registering of databases or when you want to manually add services to the listener. Let's close Net Manager. Discard any changes you may have done. Let's see where these files are located. Change directory to $oracle_home/network/admin. Let's type ls-l. We can see the 3 files here. Now let's do a cat on listener.ora. We can see the actual syntax for the listener. Here we can see the listener is listening on host Oracle 12 Lab on TCP/IP port 1523. Also, the listener is listening on something called IPC with a key of EXTPROC 1523. IPC stands for Inter-Process Communication, and this is used by programs that are not part of the Oracle stack. These are called external procedures. Let's do the same now for tnsnames.ora. We can see the aliases syntax. An alias is composed of 3 parts: the alias name, the address list section, and the connect data section. You can have one or more addresses for one alias. The service could be running on one or more hosts and/or different ports. The connect data section defines the name of the service and what kind of connection we'll be establishing with the database. And finally, SQLnet.ora. Here we can see we only have the name resolution set to TNS names and hostname. Now let's see how to use the EasyConnect method. Remember that for EasyConnect we only need to know the hostname, port, and service name. Let's try SQL+ command. Notice we are escaping the double quotation mark with a backslash. This is so the Linux shell passes the double quotation mark to SQL+ instead of resolving the content at the shell level. EasyConnect is very useful for quick connections. Let's try now TNS alias. Let's connect to system using the test alias. For that, we do SQL+ system add test. If next month I migrate this database to a different host, I just need to update the alias in tnsnames.ora to point to the new server. I don't have to make modifications to the application as long as I don't change the name of the alias. Finally, let's review how to manage the listener process. So far, we know how to check the status of the listener by running listenerctl status. If we need to stop the listener, we just type listener control stop, and this will shut down the listener. We can check the status again to verify it's not running. To bring it back up, we run listener control start, and this will start it back up. We check the status again, and the listener is running now. We can see that the listener doesn't have any services registered. The database will register in a moment by itself, or we can force this. Let's open a SQL+ session, then run alter system register. This will force the service registration with the listener. Let's check the status again, and there they are, all the missing services. In this module, we learned how the connections are established between the client and the server, or the different methods to connect to the database. how to configure the listener, TNS names, and SQLnet using Net Manager. We learned how to connect to the database using the two most common naming methods, EasyConnect and TNS alias. Lastly, we review how to stop and start the listener and how to force service registration through SQL+.